This symbol over here that looks like a stretched out S is actually just an integral sign. And so what we're looking is for the integral of this function. This function, if you look at it, has a lot of terms in it. And I've highlighted all the terms in a different color so that you realize that they're all different terms. We're going to integrate each one of them separately. Using the above formula here for integration, if you have x to the power of n, all we're doing is adding to the exponent 1 and then dividing it by n plus 1. And we then add a constant c, which we'll do that at the very, very end. So to start off with, our blue term can be integrated by saying it's x, 4 plus 1 is 5 over 5. And now we'll integrate the green term, and that'll be x, add 1 to the 2, that's 3, divided by 3, and there's a minus in front of it. Now we're going to do the same thing to the orange, and we'll have minus x. This x here has got a 1 on it. So we can pretend that we're going to add now a 1 to it. So this will be x to the 2 over 2. And when we get to the constant, we're going to be using this formula here, where the k is a constant. When there is a constant, we need to add an x. So that means that this pink number 2 is going to be 2x. And finally, to finish off, we add our constant c to this. Now we can practice with another one, and at this time I'm not going to be using different colors, but we will move term by term. So first of all, with the first term, the exponential 4 is now increased by 1, so it'll become 5. So we will have 5x to the power of 5, but we're going to divide this by 5. The second one, we have x to the power of 4, but there is a 4 in front, and we're going to have to divide it by 4. And the third term, we've got x squared, so that x becomes x cubed. There is a 6 in front of it, a constant, and we're going to divide it by 3. And lastly, we have just a constant 7, so that 7 is going to be multiplied by the x. And the very last thing we need to do is to add the constant c. But we also should simplify this. We do not need the 5 and the 5, so this would just become simply x to the power of 5. We also don't need the 4 and the 4, so this will be just x to the power of 4. And in here we can just divide that by 2, and we will just have 2x to the power of 3. And the last one stays, minus 7x, and it's followed by the constant c. And here I think I might have chosen a more challenging one, but it's not really that hard. Before I integrate it, I'm just going to rearrange this one, because you notice that I've got x and x to the a half. So you might want to see this in another way. It's x to the 1, x to the a half. That's not quite it. I'm going to do this one more time for you so that you can see that this really is x to the 3 on 2 minus 2. And now in this form we actually can integrate it. So this will end up being if we add 1 to that exponent 3 on 2, we'll get 5 on 2. So we might say that we have x to the 5 on 2, and we must divide it by 5 on 2 as well. And the second term, minus 2, will become 2x, and we add a constant to this. We want to rewrite this one more time because it's not nice to have a fraction underneath in the denominator. So we will write that as 2 on 5 x to the 5 on 2 minus 2x plus the constant. And if you want to be a little bit more picky, I will rewrite this again, 2 over 5, and x 5 on 2 is x squared root x minus 2x, and we add on the constant. And I'll finish off with another example, and this time it'll be 1 over x root x plus 4x dx. Once again, it's best to rewrite this again, and we know that x root x is the same thing as what we did above over here. It's x to the 3 on 2. And if I want to move it up to the numerator, it'll just become x to the minus 3 on 2 plus 4x. Now we can integrate this, and remember that we're adding 1 to the exponent. So in that case, if you add 1 to negative 3 on 2, it'll be x to the minus a half over minus a half. And our second term will be 4x to the 2 over 2 plus the constant. Now this part over here looks very, very ugly, and x to the minus a half, it can be now written in the denominator. And when we divide by a negative a half, we can say we're multiplying it by negative 2. So we'll have negative 2 over the root of x plus 4 and 2 cancel out to 2x squared, and now we just add a c. And these few examples just came from page 117 in exercise 4E1, question 1. The next video will be on integrating exponential functions, EX.